Well, hello this evening. Good evening and welcome to the final installment of Rock Valley College's first Tuesday lecture series for spring 2016. I'm Susan Busenbark and I'm the Vice President of Liberal Arts and Sciences. And it's my pleasure to tell you a little bit about tonight's speakers. Professor Steve Fleeman joined the Rock Valley College faculty ranks in 1982. His career spans 33 years in education and in industry. He earned his bachelor's degree in electrical technology and his master's degree in industrial education from Purdue University in the 70s. We won't get specific. Yeah, okay. He holds membership in numerous professional associations, including the Institute of Electrical and Electronic Engineers and the Illinois Renewable Energy Association, and served on the EET Advisory Board of Northern Illinois University. Among his professional accomplishments, Steve developed curriculum, a textbook, and an AAS degree with a renewable energy emphasis. Steve's educational philosophy states, with the exception of being an elected official or one of the clergy, seldom can one's actions or inactions have such far-reaching effects on so many others. Steve's students benefit from his thoughtful dedication to this premise. Dr. Tom Lombardo is an alumnus of State University of New York and Northern Illinois University and has been a valued faculty professor at Rock Valley College for 25 years and was selected by his colleagues in 2001 for the honor of Faculty of the Year. Dr. Lombardo earned his doctorate in education from Northern Illinois University in 2011. Please join me in welcoming Steve Fleeman, Professor Steve Fleeman, and Dr. Tom Lombardo.
Thank you.
So I'm Fleeman. That's Lombardo. Just make sure it's straight.
I graduated from college in the 80s, by the way, not the 70s.
We're going to be, you got the, okay. We're going to be looking at coping with the smart grid by using a smart home.
And feel free to raise your hand and ask questions as we go. You don't have to wait until the end. And please ask a lot of questions, because we only have like 5 minutes worth of slides, so we need to kind of stretch this out. No, just kidding. Okay. So just kind of an overview of what we're going to talk about tonight. We'll start with by discussing today's electrical grid and talk about the problems associated with it, how the smart grid will affect consumers, that's you, smart home technology that may be coming your way very soon, how to save money on your electric bill, because our electric rates are about to change very quickly, and there are ways that you can save a good deal of money this way. And we'll talk about smart grid education at Rock Valley College, because we have a program that deals with exactly this. So,
with the rollout of the smart grid, one of the first things you're going to notice is the opportunity to change your status as just an energy consumer to an energy citizen. Now, energy citizen, we can reduce our bills and support the environment, and more notably, renewable energy. The first indication that the smart grid is coming to a home near yours is when a technician comes out and removes the old analog spinny dial meter and replaces it with one that has a digital readout. The thing that makes that meter smart is the fact that it actually communicates between your home and utility. And that dimension of communication is the first time that's been available.
What makes the meter smart is it has a little microcontroller inside of it, and I had to plug that because that's the course I teach. So. Okay.
With the smart grid, one of the things you'll see is that you're going to have the opportunity to do online energy management. You've got usage tools like for high usage, weekly reports summarizing daily energy usage. If your utility is ComEd, this is available as soon as you get your smart meter. Voluntary peak time, peak energy reductions. The key here is voluntary. So if you want to help reduce your rates, you can make decisions about the plan that you elect from your utility.
Yeah, the alternative is to volunteer to pay extra money. So it's voluntary. You have a choice. Okay, well, just a very brief dip into history. Thomas Edison was a big proponent of DC electricity, and he proposed the first centralized power station His idea was to put a power station basically every couple of miles. His rival, who used to be his employee, Nikola Tesla, everybody's heard of Edison, only geeks like us have heard of Tesla. But we're geeks, so we've heard of Nikola Tesla. Nikola Tesla was an advocate of using AC electricity, and because it was much more efficient to transmit over long distances. And eventually Tesla won and basically designed the grid as we know it today. And just to show that we really are geeks, I have a Tesla Edison t-shirt. But the current grid is still 19th century technology. We're dealing with technology that's over 100 years old. There have been very few changes to the grid as we know it in the last 100 years or so.
The topology of the grid as we know it today is the whole notion of having centralized power generation thanks to transformers. We can now elevate the voltage, raise it to hundreds of thousands of volts, and then it goes down the line to reduction through another transformer, and then finally distribution, and then reaches the industrial, business, commercial customers, as well as our residences. The grid in the mainland is pretty impressive when you look at, it's all that it encompasses. It's broken down to 3 separate grids in the United States. We have the Western grid, the Eastern grid, and the Texas grid. And Texas has its own grid because, hey, they're Texas. One of the problems with the current design of the grid is it's susceptible to what we call single point failures. Anywhere along the line, and if it's close to the generating plant, the effects are going to be more widespread and felt. You go all the way down through substations and finally the end user. If a squirrel bites through your power lines, you could lose power and your neighbors. The interesting point, though, how would your power company or the utility know, if you had a problem? You're going to make a phone call. And so as you'll see, that's part of the reasons for having communication with the smart meter.
Yeah, currently, if the electric grid goes down, if any part of the electric grid goes down, the way that ComEd knows about it is when you make the phone call to them. So they have no way of knowing other than when customers report outages. Does anybody recognize that photograph? Can you tell me what that is? That's a satellite image of the United States at night. So all those white spots are lights coming from big cities. So hopefully you can identify Chicago here. All right, there's Detroit, Cleveland, Buffalo, which is where I'm from, Toronto up here, Niagara Falls. In 2003, that's the way everything looked. And there was a thunderstorm going on somewhere in Ohio. And in that thunderstorm, a tree branch blew down from a tree, hit one of the power lines, and a split second later, it was that. Okay? Literally, that is a satellite photograph from that blackout. Okay? Let's go back and look at this, okay? You see how you can see the outline of the Great Lakes here? You can see Lake Michigan, Lake Erie, Lake Ontario, a little bit of Huron, okay? Nothing. The whole Great Lakes area east of Lake Michigan was taken out. And that power outage lasted for about 3 days. Okay? That whole area was blacked out for 3 days, no power, from one tree branch colliding with one power line. Okay? Now imagine what a terrorist could do to our power grid. And it's kind of lucky that it hasn't happened yet. So there are some really significant vulnerabilities in the grid as we know it today. Some of the things with the smart grid that will affect you as a consumer is it will be, to a certain extent self-healing. So when there is a failure, one thing that will happen is power will be able to be routed around that failure so they can localize just the region where wherever the failure occurred, only the immediate region will be affected. And so that's one thing. The other is for the grid to be able to inform the utility where the outage occurred so they can make faster repairs. Okay? A lot of this other stuff You have the utility here as being energy producers, whether they're doing traditional energy or solar and wind. You have a grid operator over here. And then on the home side, we have smart appliances. We will have smart appliances and smart meters.
One of the problems with the grid inherently is because we generate the power at a remote location, and we have to get that power from generation and transmission and distribution, and the efficiency can be as low as 30 to 51%. So that's a lot of lost energy. If we could reduce it, improve the efficiency, that's equivalent to like making more generation plants, just by doing things in a better fashion.
Yeah. Some of the losses are just inherent in the way that we generate power. When you burn coal or you burn oil to generate electricity, most of that energy actually goes to heat, and very little of it is actually converted into electricity. So less than 50% of the energy in a hunk of coal is converted into electricity when you burn that. Okay? The rest goes off as carbon and heat. However, the part that we're really interested in is this transmission and distribution. We lose 8% of the energy that comes out of this power plant is lost before it gets to the consumers. And part of the reason for that is we have so few power plants and that the distribution goes very, very long distances.
A lot of people, when we talk about the smart grid, some of you may be astute and actually looked at your bill and maybe saw some kind of smart grid charge, 50 cents, 75 cents. I wonder what that's all about. But a lot of people immediately assume that it's utility and it's just a scheme to try to get more money, I won't go there. But the smart grid effort is worldwide, from Africa, Asia, Australia, Europe, North America, and South America. There's everybody has the same kind of problems with the grid, its inefficiency and issues with reliability. So it's not just like ComEd's plan here, it's a nationwide, worldwide initiative.
So the Department of Energy, U.S. Department of Energy, came up with 7 goals for the smart grid when they came up with this idea in 2010. One is more efficient transmission of electricity. As we said, 8% of our electricity is lost just in transmission. A faster return to service. So when there is a failure, they want to be able to fix that quickly so we don't have 3-day outages like we had back in 2003. They want to reduce the cost for the utilities. Of course, ComEd's interest is in reducing costs for utilities. Our interest is in helping you reduce your costs. It's good for everyone. Reducing peak demand. We'll talk more about this later, but if you were to look at when energy is being used, most of the electricity that we use is in the mid-afternoon to the early evening. And unfortunately, the power company has to be capable of generating whatever your peak demand is. They have to have that generating capacity all the time available. That's very expensive for them to do that. So they would like to kind of level that off a little bit. Of course, we want to move away from coal-burning power plants and non-renewable sources and move towards renewable energy systems. The thing about coal is you can rely on it. You've got this supply of coal, and if you keep it burning, you'll generate a certain amount of electricity. Renewable sources like solar and wind, you may have a cloudy day. We can't necessarily count on that. Now, that doesn't mean that these are not good sources of energy. It just means that the grid has to be a lot smarter in how it doles that energy out. And also, people are putting solar panels and small wind turbines on their properties, and they want to be able to, we're now power producers. It used to be a one-way, you bought your power from the utility. Now we're able to produce some of our own electricity and put it out on the grid, and the grid is going to have to be smart enough to know when to accept that and how much and all of that. And of course, improved security. As I said, if a tree branch can take out 1/3 of the northern United States, then think about some of the other things that could happen.
And distributed generation means putting a generator right next to the load, so you don't have all the transmission lines. So the strategy is get things closer.
Yes, Brian.
Can you clarify that point? You said that home windmill or a home solar panel would contribute to the whole smart grid, or just for your home?
Okay, good question. Question was, if you have your own solar panels or your own wind turbine, can you sell energy to the electric grid? And the answer is yes, you can. There's a process called net metering, and right now net metering laws say that if you have a renewable energy source of electricity, you can have it connected to, and now you have to get approval from the utility, but by law they're required to do this. You can sell, if you're generating more than you need at any given moment, you can sell electricity to the grid. Currently, that's at retail prices, which means you're selling it to them at the same rate at which you buy it from them. So for all practical purposes, your meter spins backwards when you're generating more than you use. Yeah.
Just to contrast the traditional versus the smart grid, again, the power generation at the top is at a power plant, transmission, distribution, and then finally reach the customers. The smart grid makes allowances for a lot of local distributed generation. And so you see in the center there's a wind farm, there's also a solar farm, and there's a lot of those appearing around Illinois still. The problem is the wind farm and the solar farm are what we call intermittent. You can't always count on them. And when you're trying to run the grid, if load increases for whatever reason, you need to increase your generation capability. So that's one of the things that has to be included. In Illinois, we have something called the Renewable Portfolio Standards. So the power companies are supposed to provide 25% of energy generation from renewable sources by 2025. And there's still some debate on that. They're trying to change the law a little bit to energy delivered from generated. Here we have just the smart grid essentials. The big thing you see is the consumer portal and building energy management system. That would be the smart meter. As Tom has mentioned, putting solar panels on your home is a good way to reduce your electric bill. I will tell you though, never put a wind turbine on your roof. They make noise and they don't perform well. So whoever tries to sell you that, no. But you see distributed generation storage. The new grid, the smart grid, makes provisions for like plug-in hybrids and electric vehicles. So this is all building in the new technology. The big thing now that, and if I'm getting announcements from ComEd about the smart meters going to be here and giving you the option to save money. The flat rate is going to go away. And this is part of the strategy for utilities, again, across the U.S. and across the world. Time of use rate plans, there are going to be higher rates for your electricity prices when the demand is high. This means when you use energy is just as important as how much you use. So as users, if we want to manage our bills and try to reduce them, we have to take some of this into account.
So one of the things about time of use pricing is there will be different times of day and different prices for electricity. So over here we're looking at one potential pricing scheme. In the winter, on weekdays from 9 at night until 7 in the morning, this green area, this is when it's good to buy electricity. It's very, very inexpensive during these times. Yellow is when it's kind of medium, and red is when you really want to avoid buying electricity because those are the times when, those are peak demand times, and that's also peak rate times. They're going to start charging us a lot more money to buy electricity here and here than during the green and the yellow periods. Okay? These times are based on, you got this from, it's a certain utility. Is it ComEd?
This is not from ComEd, but we'll get to ComEd here in a bit.
So there are other utilities in the United States that are doing this already, and so we got some data from those. We don't know exactly what ComEd is going to do, but it's going to be very similar.
But if you look on the left, when people get home at 5 o'clock, what do? Forgot to run the dishwasher, got to put the pizza in the oven, load of laundry, turn on the TV. So the demand is highest at that point. So it's just like we have to take that into account. On the summer on the right, that's from roughly 11 a.m. to 5 p.m., and that's because that's the heat of the day. That's when people are using their central air. This came from ComEd, but right now, even without a smart meter, you can go on their website and see what the time of day at hourly pricing and also what is the price currently. As soon as you get a smart meter, then they have data about your particular residence, and you can also get your usage.
Right now, this information is largely for businesses and industry, right? Because they're already paying.
They're getting ready.
Yeah. So business and industry has known this for a long time. They've been paying demand charges and they've been paying time of use fees. But it's just recently that it's starting to come to the consumer.
So with smart home technology, real-time monitoring can help us control costs, and we'll talk about some of those applications. Smart home technology makes the process much easier. You can program like your thermostat and have it make decisions about pricing. So it can set the temperature a little lower or a little higher depending on what you want to do and what the price is.
And if your thermostat is blinking 12 o'clock, there's a thermostat called a Nest, which works on a dial, and you don't have to program it like regular programmable thermostats. So.
The smart grid meter provides two-way communication, so from your home to the utility, energy management and utility control. And when you say utility control, that really raises a red flag for a lot of people. I don't want the utility coming in and adjusting my thermostat, thank you very much. And basically they can't do it, but you can sign agreements so that you get a reduced rate if you permit the utility to have a limited level of control.
Yeah. The alternative to that is you end up having brownouts or blackouts in your area because people are demanding more electricity than what they can provide. So it kind of is, you know, it can be imposed upon you if nobody cooperates.
This is a smart grid meter. Now, some terminology, like as soon as you start buying like smart home products, the home area network, you know, most of us like local area network. Well, that's home area network, and we also have the neighborhood area network. There's a standard called ZigBee, which is right in there with Wi-Fi and Bluetooth and some of the other wireless technologies that we come to rely on. ZigBee, like a lot of the products now, the thermostat, power monitors are all going to be compliant with that standard. The utility designs a communication protocol for the neighborhood. So it could again be ZigBee, or it could be Wi-Fi, or it could be a cellular uplink.
Go ahead.
Okay. Here you just see the utility and the neighborhood area network. On the left there we have the smart meter, the residences, maybe some small businesses. Because the utility is going to have real-time data on how much energy is required and how much energy is being used, they can control their operations. So SCADA is supervisory control and data acquisition. One of the other things, a difference, like you can buy some modules now, like these little Belkin Wemos, as they call them. And what you can do is there's an application, so you can use your smartphone. You can monitor the energy use by a light bulb or any appliance. When they try to market this thing, it's like, well, you know, if you used one for your iron, you know, and then you left home, you'd never have to like worry about having left the iron on because you can shut it off remotely if you got the application. The other stuff, the ZigBee, the difference between that is each of the little modules can talk to one another. Some of the people that use the Wemos, if your device can't see the wireless modem, it may not communicate reliably. So sometimes you have to get a repeater or move the modules around.
If you have a Wi-Fi network at home, you might find that your Wi-Fi router, if it's not centrally located, where the internet comes into my house is in the one remote corner of the house. And so my Wi-Fi router is there. If my wife is all the way in the other end of the house trying to use her laptop, quite often she doesn't get a good signal. And so what I did was I bought a repeater, so it goes halfway in between and it amplifies the signal. And that's what you have to do with Wi-Fi because there is one central router. With ZigBee, let's say this is my smart meter that has my router here, and this device wants to talk to that one. If it's too far away to make a direct link, it can just kind of hop a signal through its neighbors. So every one of these devices on the network is capable of passing communication along. So in a sense, you've got repeaters with all of your devices built in.
This is just a ZigBee internet connection. Again, on the far right, you've got the ZigBee network. Again, this could be your thermostat or power monitor. We have to have some sort of gateway that links with the modem. The gateway can, and usually is, like part of a smart thermostat. It could be a separate unit, but generally it's been integrated in the overall system. This just gives you an example of, with the smart meter, we can communicate with a thermostat. It can go beyond just like setting the temperature when it snaps on, off, or putting in time of day. If it's smart, it can actually receive pricing information. And you can program in it, okay, I want to, if the price goes up above a certain point, you might want to throttle back on the thermostat.
So right now in the summer, you might have your thermostat set for, say, 78 degrees, nice comfortable 78, and if it gets above 78, your air conditioner will turn on. In the smart meter scenario, the smart grid, smart home scenario, the thermostat, before it turns the furnace, or I'm sorry, before it turns on the air conditioner, the thermostat would consult with the smart meter and say, what's the price of electricity right now? And if the price is really high, the thermostat, and again, this is something you would program into the thermostat, you would say, I don't want to pay more than X amount for electricity. So if it's higher than that, you can raise the temperature of the house a couple of degrees, not a big deal. Okay? And so the thermostat can ask the smart meter, hey, when's the price going to be low? And if it's an hour from now, then maybe the thermostat decides, you know what, the air conditioner can stay off for another hour and will save you a lot of money and won't really affect your comfort level all that much.
Here we have solar modules. We'll talk about those. But right now, solar has become very, very inexpensive compared to the way it was like in 2009. One of the technologies that's available now and widespread is something called a microinverter. Like sometimes you hear, well, you know, I want to put 5,000 watts of power on my roof. And you start looking at the investment, and you know, then you talk about payback and do the calculations. Now you can kind of build them as your budget permits. You don't have to put 40,000 watts up or 10,000 watts or 5,000. You can start with 250 watts at a time. So it makes it a lot more attractive.
Okay. Smart appliances. We talked about the smart thermostat, but you have other appliances that don't necessarily have to run all the time. For example, your refrigerator. Your refrigerator, even though it's plugged in 24/7, the compressor is only running maybe about 15 minutes out of every hour. And so it senses what the temperature is inside the refrigerator. When it gets a little too warm, it runs the compressor to cool it down. The smart appliance, the smart refrigerator, would be able to, again, just like the thermostat, look at the smart meter, ask what the current electric rates are, see, is it reasonable to let of course it's not going to let your food spoil or your beer get warm, so don't worry about that, okay? There's fail-safes in there. But if it can wait a few minutes to turn on the compressor, then it will do so. More importantly are things like your washer, your dryer, your dishwasher, okay? Those are all things that presumably, unless you only have you don't have any clean shirts and you got to go somewhere and you have to wash right away. But most of the time, you could probably delay a wash. So a smart washer, a smart dryer, a smart dishwasher, well, again, it'll look at the smart meter, look at the electric rate, and decide maybe you can wait an hour for your dishwasher to turn on. And again, it's something you can override, but you can tell the dishwasher, hey, just set everything ready to go, push the button, and maybe it doesn't start for another 2 hours because that's when the electric rates are low.